Welcome to This Explainer. Okay, if you've been paying any attention to the industry lately, you know we've spent years obsessing over models and parameters and lines of code. But honestly, the landscape has completely shifted. Today, we are diving into how AI has officially exploded out of the software lab and right into our messy, massive physical reality. We're talking about a world where AI is actually reshaping hardware, dictating international diplomacy, and even learning to perceive the physical dimensions of space and time. So what really happens when the AI race makes that jump into the physical world? Let's think about this for a second, because the latest developments show the AI tech stack maturing at lightning speed across every single layer. We are way past the days of dealing with abstract algorithms just floating in the cloud. We are now dealing with physical supply chain bottlenecks, industrial scale extraction, and systems that are aggressively embedding themselves into enterprise operations and real-world robotics. All right, here is our agenda for today. We are going to explore this stack from the ground up. Custom silicon, global infrastructure, industrial espionage, enterprise agents, and finally, 4D vision. Let's kick things off right at the physical bedrock with number one, custom silicon and OpenAI's new Jalapeño chip. Late in June, OpenAI and Broadcom dropped a pretty massive reveal, Jalapeño. It's a custom inference chip built completely from scratch. To really get why this is such a game changer, we need to understand what an ASIC is. Jalapeño isn't some general-purpose chip trying to do everything for everyone. It is heavily specialized. It's actually a reticle-sized chip, which basically means it is as physically large as a piece of silicon can currently be manufactured, and it's architected specifically for the intense memory and networking demands of frontier AI models. This completely shatters the industry's heavy dependence on a single chip supplier, and it gives OpenAI unprecedented control over its own performance roadmap. But honestly, the absolute craziest part of this story is the timeline. Taking a massive, complex chip from initial design all the way to manufacturing tape-out in just 9 months, that is widely believed to be the fastest development cycle ever achieved at this level of performance. And ironically enough, they actually used AI models to accelerate that exact design process. They're already running real workloads in the lab, and they are targeting initial deployment by late 2026, alongside some massive plans to scale into gigawatt-class data centers. Which leads us perfectly into layer 2 of our stack, global infrastructure and the scramble to secure the supply chain. Because governments are absolutely waking up to this. The US State Department just launched this new multilateral AI opportunity partnership, and it represents a total pivot in international diplomacy. We're moving away from the old reactive focus on just mitigating risk and restriction and shifting toward proactive shared infrastructure. It's all about trusted collaboration and fair competition now. We are talking about real physical assets here. Aligned nations are now formally cooperating to lock down the exact physical resources needed before the next massive wave of AI hits. Think about it, the critical minerals pulled straight from the earth, the insane energy supplies required to power those gigawatt data centers, raw compute capacity, and semiconductor manufacturing. It is a full-on race to establish a shared physical foundation, which is going to make cross-border data agreements so much smoother for businesses moving forward. Of course, when physical assets become this incredibly valuable, they become prime targets. That brings us to number 3, industrial espionage and what we're calling the Great Model Heist. Let that massive number sink in for a second. 28.8 million. That is the number of fraudulent exchanges that Anthropic claims entities connected to Alibaba's QuenLab generated. And this wasn't over a year. This happened across just a few weeks, utilizing around 25,000 fraudulent accounts. What were they after? They were trying to systematically extract Claude's highly regarded software engineering and agentic reasoning capabilities. Now, this wasn't your run-of-the-mill cyber hack where someone breaks into a server and steals source code. It was a distillation attack. Think of it as industrial-scale reverse engineering. Effectively, they were feeding millions of carefully crafted prompts into Claude, recording those perfectly reasoned answers, and then using those exact outputs to train their own smaller model. It's a way of transferring years of incredibly expensive knowledge without ever footing the bill for the underlying research. The real takeaway here is just how seriously lawmakers are treating this. Anthropic's head of policy actually testified about this, calling it a systematic harvesting operation at an industrial scale. And we are already seeing bipartisan efforts moving in the U.S. Senate to formally sanction this exact kind of extraction. It really proves that protecting AI is no longer just a basic cybersecurity issue. It has become a defining global policy challenge.
All right, moving up the stack to the application layer. Number 4, enterprise agents. We are absolutely reaching a tipping point here.
Just consider this explosion in adoption. A massive 72% of organizations now have AI agents running in live production environments. Gartner is even projecting that 40% of enterprise apps will embed task-specific agents by the end of the year. I mean, that is a faster adoption curve than we saw with mobile technology. A huge catalyst for this was Microsoft dropping their WorkIQ APIs, which finally solved a major bottleneck. It allowed these agents to be securely grounded in actual company data, like emails and calendars and files, creating a real semantic model of how a business actually runs day to day.
But, and this is a really big but, there is some dramatic tension in the market right now. While adoption is just going through the roof, a staggering 60% of these companies are reporting huge governance gaps. They literally lack the tools to audit, monitor, or control what these embedded agents are doing behind the scenes. Because of this, major consulting firms are entirely shifting their focus from just deploying the AI to frantically building out the governance infrastructure needed to keep these systems safe and accountable. And finally, we reach the absolute cutting-edge top of our stack, number 5, 4D vision, where AI officially gets spatial intelligence. So at the CVPR 2026 conference, which is pretty much the premier event for computer vision, researchers unveiled an award-winning system called D4T. Up until now, most AI video models basically understood the world in flat 2 dimensions. D4T is totally different. It actually grasps the 3 spatial dimensions you can see, plus the dimension of time, allowing it to understand how every object in a scene moves and changes. Here is how it works under the hood. It takes totally ordinary, standard video footage, and then it separates the static background structure, like the walls or the road, from the dynamic moving elements, like cars or people walking by. Then it actively reconstructs how every single object is changing in space, all simultaneously. It is effectively making sense of our incredibly messy, constantly moving reality. This is a monumental breakthrough. It solves one of the biggest hurdles for machines trying to interact with the physical world. Understanding 4D geometry is exactly what self-driving cars and interactive robotics desperately need to be reliable. Instead of depending on insanely expensive, specialized sensor rigs, these industries can now pull rich spatial intelligence straight from standard video cameras. We are very likely going to see these capabilities hit commercial robotics and self-driving platforms within the next 6 months as this tech moves out of the lab and into the streets. So I want to leave you with this final thought to ponder. We've seen today how fast AI is scaling, from printing custom Jalapeño silicon to forcing the global realignment of physical supply chains to triggering industrial-scale espionage and embedding itself into the core operations of almost every major enterprise. As all of these distinct layers converge, what exactly will AI do now that it truly deeply understands the physical dimensions of the space around us? Thanks for joining me on this explainer. Keep your eyes on the physical world, folks, because for sure, that is exactly where the AI revolution is happening next.